Welcome back to geometry, or welcome for the first time if this is the first time you've ever watched a video. So we are going to review some coordinate plane stuff and midpoint and distance formula and Pythagorean theorem. It's going to be a grand old time. So starting off, just a quick warm-up. To graph AB, we need to plot the points -2, 3. So remember, it's x and then y, so we need to go left 2, 1, 2, and up 3. And that gives us A, and then B is at 1, 0, so we would go right 1, and we don't go up or down at all. And then we just connect, boop, like that. So then the length of CD, you are just counting 1, 2, 3, 4, 5, 6. So CD is 6. In order to find the midpoint of CD, midpoint, mid means middle. So looking at the middle, that would be right here on the y-axis. So if I want the midpoint of that, I got rid of all my points. I need this point right here. So my x value, I don't go left or right, so it's just going to be 0, but I do go up 3, so it's going to be at 0, 3. For number 4, simplifying, we need to take care of our parentheses, big set of parentheses first. So we would have the square root of, instead of 3 minus -1, it'd be 3 plus 1 squared, because minus a negative turns into 1 big fat positive. So then 3 plus 1 is 4, and that is getting squared. 4 squared is 16, and then the square root of 16 is 4. Now, some of you may have also noticed that this squared and this radical right here would cancel each other out, and you would have just gotten straight to 4. So if you did that as well, that is also fine. So then we want to use Pythagorean theorem to solve for AB and figure out how long it is. So looking at this, I always picture these as a hypotenuse. So if I'm going to draw a right triangle, I need to come down and across, so I have that right angle. So if I want AB, I need to figure out how long these are. So for my horizontal line, I have 1, 2, 3, 4, 5, 6. And for my vertical line, I have 1, 2, 3, 4, 5, 6, 7, 8. And literally just counting. So then Pythagorean theorem, if you recall, is a squared plus b squared equals c squared. So then a and b, remember, are the legs, the things that touch the right angle. So we would have 6 squared plus 8 squared equals c squared. And in case it helps you, you can label this as c. 6 squared is 36. 8 squared is 64. And 36 plus 64 gives you 100. So then in order to get c by itself, you have to take the square root, because just like above, the square root and the squared cancel each other out. So then we get that c is 10. Boom, done. So our midpoint formula, so when anytime we want to find the midpoint of any line, whether it's straight or whether it's horizontal, vertical, or diagonal like this one, is you add the x values together and then divide it by 2. And then you add the y values together and divide by 2. And notice that is your ordered pair. So you should have your x and your y still. So to actually put that into action, we want to find the midpoint of EF, which has -2, 3, and 5, -3. So we are going to take our x values first, and we are going to add them. So it is going to be -2 plus 5 divided by 2. And then my y values is going to be 3 plus -3 if you want, or you can just put 3 minus 3 and then divide by 2. So then when I do midpoint, -2 plus 5 is 3. So I would have 3 over 2. And then 3 minus 3 is 0. So 0 divided by 2 is just 0. So then if you want to double check this, 3 over 2 is 1.5, which should be right here. And 0 means it's on the x-axis. And you notice it is right smack dab in the middle of that line. So you add the x values of the 2 points that you're trying to find the midpoint of, and then you just divide them by 2. So then I want to find the coordinates of mn with endpoints -1, -5, and n at -6, -3. So again, with this formula, we are going to add the x's together. And for some of you, it might be easier if you just come off to the side and you know you have numbers that are going in there and you're going to calculate them. So if I want to find my x value, I'm going to do -1 plus -6 divided by 2. -1 plus -6, or -1 minus 6, is -7 divided by 2, and we can't do anything with that, so it's just -7 over 2. So then, to find the y value of your midpoint, you add the y values and you divide by 2. So -5 plus -3 divided by 2, that gives us -8 divided by 2, which gives us -4. Okay, and that is our midpoint. Yay! All right, so then distance formula is similar, but the distance formula is used to find the distance between 2 points. And so it is the square root of x1 minus x2 squared plus y1 minus y2 squared. And actually, fun fact, distance formula is actually very closely related to the Pythagorean theorem. It's actually exactly the same, it's just a different way of writing it with different terms. So, if I want to find the distance between k and e, I have -2, 3, and 3, -5. So, my distance is going to be the square root of the difference of my x's, so -2 minus 3 squared, plus the difference in my y's, which are -3 plus -5 squared. So then, to simplify, we do the parentheses first. -2 minus 3 is -5. And then -3 minus 5 is -8. So that's going to be -5 squared plus -8 squared. 5 squared becomes 25, and -8 squared becomes 64. So then 25 plus 64 gives you 89. So we just have the square root of 89, and we don't have any other answer beyond that. Now, if you wanted to use the Pythagorean theorem, what I would say is, if you think back to the beginning when we had, where's it at? Right here, when I found this length, technically I'm doing the difference in my x's because it's 4 minus -2, which is 6. And then when I do the difference of my y's, which is the vertical part of this, I would have 7 minus -1, or 7 plus 1, which is 8. So if you prefer, you can just, you can draw a right triangle or think of it in that way, because then you're just using Pythagorean theorem. So we are going to use the distance formula to find FG and JK and then determine if they are congruent or not. So first we need to find the coordinates of all these points. So F is 1 to the right, so that is 1 for the x, and up 2, so that is 2. G is 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 up. J is 1, 2, 3, 4 to the left, which would give us -4, and it doesn't go up or down, so it's just 0. And then K is left 1, so -1, and down 3, which is -3. So then, if we're going to do distance formula, we're going to start with FG. FG is going to be the difference of our x's, so 1 minus 5 squared, plus the difference in our y's, 2 minus 5 squared. So then we get the square root. 1 minus 5 is -4 squared, and then 2 minus 5 is -3 squared. So then we get that 4 squared is 16 plus 9. That gives us the square root of 25, and I'm running out of space, so no. Square root of 25 is 5. So we know that FG is 5. So then, when we want to find JK, we're going to do the same thing. Let's hope it also equals 5. We have the distance is the square root, x value subtracted, -4 minus -1 squared, plus 0 minus negative 3 squared. So then, negative 4 minus negative 1, that turns into a big fat positive. So negative 4 plus 1 is positive 3 squared. And then 0 minus negative 3 is again a positive, big fat positive. So that becomes another 3 squared. So then we have square root of 9 plus 9, which is the square root of 18. So we have the distance of both, but unfortunately they are not the same. So congruent means they are the same. And so we have 5 equal to 18. Well, that's obviously not true for the square root of 18, so then they are not congruent. And by the way, this is our symbol for congruence, the little squiggle with an equals. Okay? So, like I was saying, instead of the distance formula, you can use the Pythagorean theorem. In the right triangle, the two sides that form the right angle are the legs. Oops. And the side across from the right angle that stretches from one leg to the other side, so the green side, is the hypotenuse. Oops, I almost spelled hypotenuse wrong. Hypotenuse. All right, so in the diagram, A and B are the legs, and C is the hypotenuse. Also note this hypotenuse is always the longest side of a right triangle. So Pythagorean theorem is a squared plus b squared equals c squared. Many of you have already heard it, but in case you don't, you just take your legs, square them both, and then add them together to get your hypotenuse. So if we look at number 5, we want to use Pythagorean theorem to find the distance. So I am going to draw in a right triangle. Now, if you recall with the distance formula, you had to subtract to find these lengths. So if I were to subtract the x's, I'd give you my horizontal length. 1 minus negative 3 is 4, and we count 1, 2, 3, 4. It is 4. And then the difference of our y's is our horizontal, or we can count, but 2 minus negative 4 should be 6. So 1, 2, 3, 4, 5, 6. Yep, it is. So then for Pythagorean theorem, we would have a squared plus b squared equals c squared. My legs are 4 and 6, so 4 squared plus 6 squared equals c squared. 4 squared is 16, 6 squared is 36, and 16 plus 36 is 52. And then we take the square root of both. Now, this is where it gets kind of tricky. Technically, you could leave your answer as a square root of 52, but you do want to check to make sure there's not a perfect square in there. In this case, 52 multiplies to 4 times 13, and 4 is a perfect square. So the square root of 4 is 2, and the square root of 13 is still in there. So C is actually 2 square root of 13. Now, if you left it as square root of 52, you would still get points for it, but maybe not full credit. For the next one, if I want to find the length of JH, again, drawing that in. Counting, we have a length of 2, and this leg is 4. So to find my hypotenuse, we use Pythagorean theorem. This can be used anytime, and you're going to use it a lot in geometry because we talk about triangles a lot. But this can only be applied to right triangles. So 2 squared is 4, 4 squared is 16. So that gives us 20 equals c squared. And when we take the square root, 20 breaks down into 4 times 5. And since 4 isn't that perfect square, square root of 4 is 2. 5 stays inside the radical, and the c is by itself. Okay? So now we're just going to try it, and we're going to make it not always the c unknown. So in this case, we have a is 5, b is 7, c is unknown. So we'd have a squared plus b squared equals c squared. It's probably the last time I'll write it. But a squared would be 5 squared plus 7 squared equals c squared. 5 squared is 25. 7 squared is 49. And 25 plus 49 gives you 74. So then, let me do a quick check. 74 divided by 4 is a decimal. 74 divided by 16, also a decimal. And I doubt it, definitely not going to 25. So when you take the square root, there is no way to simplify it, so you just leave it as the square root of 74. And to check to see if it can simplify, radicals will simplify if there's a perfect square inside. Or as a multiple. So remember, perfect squares are 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, blah, 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 blah. You understand. Can be divided by any of these numbers, then you can simplify. Okay, so moving on. I'm going to go ahead and move that. So now I have a C, but I don't have a B, but it doesn't change the formula. 12 squared plus B squared equals 27 squared. 12 squared is 144. B squared we don't know yet, but 27 times 27 is 729. So then we can subtract that 144. And we get B squared equals 585. And when you take the square root, I'm just, again, going to do a quick check. 585, don't think it's divided by 4. Nope, it can't. 585 divided by 9 is 65. And making sure 65 is not divisible by anything. Not going to be divided by 9, 16. Okay, so then because 9 is a perfect square, that would be 3 times the square root of 65. And I know some of you, it's probably going to bug you that there's going to be such a big number left over. But remember, there's only so much we can do with these perfect squares. It does happen a lot that you can simplify, but it does not guaranteed. All right, so then A is unknown, but again, it doesn't change that formula. Just A squared plus 6 squared equals 12 squared. So A squared plus 36 equals 144. When we subtract the 36, we get A squared equals 144 minus 36 is 108. And then when you take that square root, A, and again, quick check, 108 divided by 4 is 27. And I'm going to actually make a note with this because 27 breaks down into 9 times 3. So I have 4 times 9 times 3. Well, 4 and 9 are both perfect squares because square root of 4 is 2 and the square root of 9 is 3. So 2 times 3 would actually give us 6 on the outside and 3 on the inside. So really, let me see, that would have been, what, 36? 108 divided by 36. Yep, 36 times 3. So if you are ever simplifying and you get to the point kind of like I did right here where you notice that you have two numbers that have to come out, the square root of 4, which is 2, and the square root of 9, which is 3, just multiply the numbers together. 2 times 3 gives you that 6. Okay? All right. So moving on down on line, we want to use the distance formula and Pythagorean theorem to find the distance between D and E. So using the distance formula, we have the square root, and we're going to subtract our x values. So we have 3 minus negative 2. By the way, the order does not matter. If you were to do negative 2 minus 3, you get the same result in the end. And then I started with 3, so then 4 minus negative 5. So I guess the only time it would matter is if you switch the order and, like, I started with D, then went to E, and then D back to E. Had I gone D to E and then E to D, that would mess up your answer. But when you're doing this, these two negatives in a row become big fat positives. So 3 plus 2 is 5 squared. And then 4 plus 5 is 9 squared. So then we would have square root of 25 plus 81. 25 plus 81, oopsie, that didn't work. 25 plus 81, there we go, is 106. Ooh. And quick check, divide by 4, no. 106 divided by 9, no. 106 divided by 16, no. Okay, very good. So that is the answer we can't simplify at all. So then if we did Pythagorean theorem and counted, we would have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we have 5 and 9 as legs. So then with Pythagorean theorem, we'd have 5 squared plus 9 squared equals c squared. Notice those are the exact same thing. And if I took the square root of c squared right now, it would be exactly the same thing. But we have 25 plus 81 equals c squared, which is 106 equal to c squared. And then when we take the square root, the radical goes away on this, or at least the squared goes away, I'm sorry, and then c is still the square root of 106. So if you have a method that you prefer more than the other, feel free to use it at your leisure. Oh, well, look at that. That's the end. Yay! So when it comes to Pythagorean theorem and distance formula, pick the one that works best for you. Just mostly depends on my mood, which one I'm going to do, and also if I'm given a picture, I am more likely to use the distance formula if I don't have a picture given to me, but if I do, then I'm more likely to use Pythagorean theorem, but that's just my personal thing. But if you found this video helpful or awesome or any of the above adjectives, feel free to give it a like, subscribe if you would like to continue watching these videos or getting notifications of said videos, and we'll see you back here soon, hopefully.